Welcome back to Logos the Return, where I split this video into two parts. First the achieved and the merit, and now we're actually on to the excellence part. The excellence part of this question states that you've got a logo design that they're wanting to make, and with this logo design we have a showing machine that cannot go below the line y equals 2, and we have to find the equation in the domain to produce this function which is down below here, which is down here, and it has to be of the form where it's quite obviously a hyperbola with y equals 3 over x plus b or plus c. Well, the first thing that we can recognize here is that if I just do this, we can recognize the fact when it says we've got y equals 2, that is basically telling us straight away that this plus c on the end is actually a 2, because when you have something a limiting part, that means basically that there is an asymptote along here at 2. So straight away it told us that there was a 2 on the end. Now the next thing that we want to do is we just want to substitute in a point. We really only need to substitute in one point. They've given us a couple, but we only really need to substitute in one point, and the point that we're going to substitute in is 0, 5. Now that means your x value is 0, which is why that there's nothing in here, and the y value is 5. So you got 5 equals 3 over b plus 2. Taking the 2 to the other side, we've got 5 minus 2 equals 3. So we got 3 equals 3 over b, and the one thing which they have missed out there is they've missed out the fact that they then changed that into 3b equals 3. They just took the b, multiplied both sides by it, so therefore they've got b equals 3 over 3, which is why they've got b equals 1. Right, so then they have got the equation straight away. They've got y equals 3 over x plus 1 plus 2, and this is all between 0 and 5. Right, the next part that they actually have to do is they have to describe that transformation, which is quite simple. The fact that this is a standard hyperbola with a gradient of 3 that has been translated to the left 1 unit and has been translated up, vertically up, 2 units. The next thing that they have to do is, this is really the extended abstract part of it, is you have to be able to take the function that was up there, and you've actually got to be able to move it in such a way to actually do what they've asked you. They want the line lower down, they want it shorter and less steep. Okay, so they want it lower down, so it has to start at a lower point, and they want it less steep. Now if you want it starting at a lower point, you've still got to have this plus 2, because there is the asymptote. All you need to do is just basically take that whole graph and move it over to the left. So if we have a standard, you've got a standard hyperbola here. Now if instead of having the line sitting at the moment, it was sitting here, if you actually, that's your axis line there, that's where you're starting. If you actually move that axis line over to here, look what's actually happened. You've had it starting, instead of at this point, you've got it starting lower down, and you know with a hyperbola it actually gets less steep as it goes towards the asymptote. So you haven't changed the asymptote at all. All you did was you just moved the axes. So to do that, to moving the axes, you are basically moving the graph to the left. So that's why we just did that. We moved the graph to the left. It meant that it started down lower and that was less steep. All you had to do was, they also asked for it to be shorter. Basically that there was changing the domain. So it was between 0 and 5. All you got to do is just choose a number, any number, just slightly smaller than it. So it could go from 0 to 3 or 0 to 2. Doesn't make any difference. This point here, you could have actually done lots of things. If you wanted it less steep, you could have had a smaller number up the top here. This is extended abstract, so there's actually, sorry about that, there's actually many different ways in which you can actually answer this question. Right, the second part of excellence here was we actually had a parabola, and we wanted to find out just exactly what the equation of this parabola was. If you set it up so your axis comes to the point so it actually passes through the origin, you're actually going to get a perfect parabola. Now basically when you go from 8 all the way out to 16. There's two ways to do it. They've actually put a point in here, but what we'll actually do is we go, okay, we're going out 8, which would actually give us 64, and then we go out 16. So then we actually have to figure out what 16 squared is, which is 256. So it's 256. So you're going from there out. So you would expect a standard one to go 256. So this is 256 here, 256. So the difference between those two numbers is how much you would expect it to go up. So it's 256 minus 64, which is 192. So you take those two numbers, this is 192. Remember, 256 was 16 squared minus 8 squared. So that jump there on a standard parabola with no number in the front would have been 192. So that is basically my expected. Remember, expected goes on the bottom. Right, what did I actually go up? There's 192 on the bottom. I actually went up 9. So therefore I must have a parabola where the coefficient in the front must be 9 over 192. So this is a fast and quick way to find out that coefficient there. Right, now you have actually got a straight line that goes across here. This is actually at y equals 3. That's from minus 10 to 10. And your other ones are between minus 16 and 8 and 16. So that's where your domain comes in. If we go down to see how we actually want to change this, they believed it would look a lot better with less steep sides and a longer base. Well, if it's a longer base, all you have to do is you're just changing your domain. So it's just minus 16 to minus 12. That would actually shorten, that would actually make the base a lot longer. Instead of between minus 16 and minus 10, which is that bit there, okay, we've actually lengthened this base because it used to go from minus 16 to minus 10. We've actually brought that base longer. Right, if we actually want it less steep, all we've got to do is just make the number on the bottom there slightly bigger. Could be any number that you want, as long as that number on the bottom is slightly bigger, so your overall fraction there is smaller than the fraction that we had originally. Because it was a standard parabola with a gradient of 9 of 192, this is now 9 over 200. It could be 9 over 300, 9 over 400. Again, extended abstract, this could be anything you want as long as that gradient is smaller. This domain could be anything you want as long as the domain part of the parabola is smaller, making the base longer. Well, hopefully that helps you understand